Hello. Today we're going to talk about creating your own data and specifically focusing upon the GeoDatabase. Today's topics will help you understand how to create your own vector data. We'll also give you an overview of some of Esri's GIS data structures and examine the GeoDatabase. Here you see the basic ArcGIS data structures. We have some vector objects that we can work with. Typically, these are shape files, or maybe historically these were shape files and coverages. The coverage being Esri's proprietary vector data set. Then we have raster objects that we can use in ArcGIS and throughout GIS in general. There we have grids and images. The grid, that specific term, the grid is Esri's proprietary raster file format, just like the coverage was Esri's proprietary vector file format. Images, when you hear that word in ArcGIS, that simply refers to any other raster object that's not a grid. So this could be our TIFF files that we've talked about quite a bit in the class, Mr. Sid files, Erdos Imagine files, etc., etc., etc. Then on the right side of this slide, you see this green canister labeled GDB. That is our GeoDatabase. Now I've depicted it in this way because the GeoDatabase is not inherently either vector or raster. In fact, the GeoDatabase can store both vector and raster objects. The GeoDatabase, as you see here on the next slide, can store tables, what we call standalone tables, vector feature classes, and raster layers. So we've used the word layer or layers quite a bit. And probably at this point it's wise to lay down some more firm definition of this term in ArcGIS. You see, all GIS data sets are considered layers in ArcMap. And even more generically, they're considered items in ArcGIS. A layer file is different than a layer. You see, a layer file is a small file, almost like a miniature project, a mini project, that you save in ArcMap to retain customized settings. This file, the layer file, refers to a layer, and that could be a shape file, a coverage, a grid, a raster, image, or a feature class, any of these sorts of things, or a grouping of layers. Then, after you've saved that layer file, you can load that layer file back into another ArcMap document, and it will display, ArcMap will display your data as you saved it with all your settings, textual annotation, etc., etc. So let's say, for instance, that you have a roads layer for the state of Idaho, and you've spent some time setting it up so that it looks very, very good. You have the roads designated, they look different. Different symbology perhaps is used for city roads, city streets versus county roads, state highways, U.S. highways, interstate highways. The shielding is all correct. The Interstate 15 labels, I-15, I-86, I-84, all the stuff is done very, very nicely. You've set some scale thresholds or scale tolerances so that when you zoom in, the labels appear, and the labels appear just as you want them with the correct font, and so on and so forth. You spent perhaps a tremendous amount of time, hours and hours, perfecting just this one layer and how it will appear inside of ArcMap. Well, at that point, it's wise to create a layer file of that layer. Then, when you want to use those same roads with all that very nice shielding and textual annotation, when you want to use that again in another ArcMap document, instead of doing that same work over and over again or trying to figure out how to copy and paste it in, which is really difficult, instead of all that, you just simply point to the layer file that's stored somewhere on your hard drive. The layer file will then refer to the feature class perhaps that it pulled in. It could be coming from a spatial database engine, a web type of connection, whatever. Pulls it all in for you, and you've just saved yourself a tremendous amount of redundant work. So I encourage you to take a look at using layer files to help speed up your map making. But what's a package? You see, a package is similar in some ways, and what a package is, the way we use a package is, let's say that we have a layer or a set of layers that we group together, and we want to share this layer or set of layers with someone else. And this data might exist, let's say, only on your hard drive. It's not available on a website, not available for download. It's too big to email. So what are you going to do? How can you share this data with someone else? Well, the solution is to use a package. So you can package your data. Again, all of the textual annotation that you've applied to it, the colors, the symbology, let's say, that all gets saved in that package file. And then you can email that package file to another user with ArcGIS. They extract that package file, they use that package file on their machine, and they will see your data just as you left it. It's a pretty nice little tool, and I encourage you to experiment with that as well. Now the GeoDatabase. Let's look at this little table that I've displayed here. There are different versions, or almost flavors, you may want to call it, of the GeoDatabase, the GDB. We'll start from the bottom of this table and work our way to the top. The first is called the Personal GeoDatabase, and frequently you'll see this with a lowercase p and then uppercase GDB. That indicates Personal GeoDatabase. The Personal GeoDatabase runs on Microsoft Access Jet Database Engine, our DBMS technology behind the Personal GeoDatabase. I should clarify that for a person to use or make use of a Personal GeoDatabase in ArcGIS does not require that the person has Microsoft Access on their machine. The only thing it requires is the Jet Database Engine, and every installation of Microsoft Windows has that engine already installed. Of course, you'll need ArcGIS to take advantage of that Jet engine. You'll see that there's no versioning support for the Personal GeoDatabase. Versioning is, in a nutshell, part of an enterprise workflow, and that's a topic that we actually deal with in detail in the information technology for GIS class, and I'll have to suffice it to say that to say just that about versioning. The maximum size of an individual Personal GeoDatabase is 2 gigabytes, and that really is a limitation of Microsoft Access and not a limitation imposed by Esri or by ArcGIS. The second type of geodatabase is called the file geodatabase, and there really is no RDBMS behind the scenes here. It's just a collection of files and folders on your hard drive that's managed by ArcGIS. So that's kind of the engine behind it, even though there is no RDBMS. Again, there is no versioning support. However, the file-based geodatabase can be very, very large. 1 terabyte per table is the size limit, so it can be very, very large type of geodatabase. Then we have ArcSDE Personal, ArcSDE Personal GeoDatabase, and that's built on the free Microsoft SQL Server Express database. This does support versioning and will work pretty well for small work groups. There's a maximum of 4 gigabytes of data that can be stored in a ArcSDE Personal GeoDatabase, and there can be 4 concurrent connections. So there can be 4 people concurrently using that GeoDatabase, and I mean concurrently using the GeoDatabase at the exact same time. Then lastly, we have ArcSDE, or what's sometimes called Professional ArcSDE. That is built on either IBM DB2 or IBM Informix, or Oracle, or Microsoft SQL Server, or the open source PostgreSQL. Differentiating characteristics of the ArcSDE GeoDatabase is one that there is the support for multi-user editing. So just like the word sounds, you can have more than one person editing a given feature class at one time. And the way that it does that is it supports versioning to its fullest extent. The ArcSDE GeoDatabase also supports spatial types, which means that the data itself is stored natively in those databases. It's not something that's manipulated, let's say, by ArcGIS to get it to fit into some sort of a database, more of a traditional RDBMS, but rather these are leveraging fully object-relational, object-oriented relational databases with native spatial capabilities. So let's look at this in a little bit more detail. Personal GeoDatabase, as I said, is built on Microsoft Access, then the Jet engine, or Jet Database engine. And one of the limitations that you should be aware of, especially when using the personal GeoDatabase, is that only vector features are actually, or feature classes, are actually stored inside the Access database. Raster data it makes it look like it's stored in the GeoDatabase, but in reality, the data itself, the raster file, the grid, or the TIFF, whatever it is stored elsewhere on your hard drive and only referred to by the GeoDatabase. And that's not a really great approach, but in reality, raster data is best served outside of the GeoDatabase, outside most GeoDatabases. There are some exceptions. For the most part, we want to keep raster files out of a spatial database engine, SDE. File-based GeoDatabase, there's the little acronym lowercase f, uppercase GDB, file-based GeoDatabase. It stores vector and raster layers in the file folder structure. This is one of the exceptions we talked about, and in fact we can leverage the file-based GeoDatabase to create what's called a raster mosaic dataset, and then use that mosaic dataset to serve image services as web services open to everyone. Cloud computing type of concept right there. There are limitations, of course, with file-based geodatabases, and one of them is the maximum size is 1 terabyte, but that is a pretty generous limitation. The ArcSDE GeoDatabase, or Professional GeoDatabase, as I've already mentioned, uses either DB2, IBM DB2, or Informix, Oracle, SQL Server, etc. There is no software size limit, and there is an